Welcome to our third video of the series on data flow diagrams. In our previous video, we took a look at the symbols for creating data flow diagrams, as well as the rules around how to use those symbols. As a refresher, here are the correct ways of creating data flows and the incorrect ways of using data flows. Now let's take the correct way of creating data flows and see an example in action. In our first video, I had presented this table of data, which we kind of figured was stock or inventory for a store, since we have different items, count, prices. This is likely data that is going to be outputted from the process of maintaining inventory. The output of stock is going to be stored in a stock file. And that output of stock, well, maintaining inventory is an ongoing process. It's not a one and done. So I'm going to rename this revised stock to be just a little bit more accurate. Another input, or I should say an input into maintaining inventory, is data about current orders. And that comes from an order history data store. Since I have two data stores, I'm going to number them at D1 and D2. Now, this doesn't mean one is first and D2 is second, but rather we're simply numbering them to differentiate them. Another input in order to maintain inventory is items sold. And that comes, in this example, from a sales system. That's right. Other systems can be a source for data into a process or into a system, as well as the ultimate destination, or what we call the sink of information out of a process or out from a system. So actors and external entities can represent roles, including the roles other systems play in the system we're drawing our data flow diagram around. Yet another thing we need data about in order to maintain inventory is stock availability. And in this example, that is something that comes from a vendor. Vendor is the source of stock availability. An output of maintaining inventory is a stock requisition, and that is output information that the vendor is a sink for. Maintain inventory is a process. I'm going to number this to be distinct with the number 2. Could be the number 3. Could be the number 99. What matters is that it has a distinct number, because there are other processes that are a part of this. Now, I haven't created those yet, but I want to show that what we're doing so far is part of a larger inventory management system. And so I've used the process symbol to represent that system. I didn't say this in the previous video, but we use the process symbol in a context level diagram to represent the system. It has a 0 because it's not a process. That's why we use the number 0 for the system. Again, it's not a process. The processes have distinct numbers to them. An input into the inventory management system that we haven't shown yet is stock order. And that is something that originates from customer. And now our context level diagram is, well, at least for the moment, complete. Now we're going to zoom back into that inventory management system, or what we call exploding or leveling. This means we're going to look at the processes that are a part of that system, which in this example is verify order details and, as we already saw, maintain inventory. As we explode this diagram, we're moving from a context level diagram to a level 0 diagram. The term level 0 comes from the notion that these high level processes, distinctly numbered, would have a point 0 after them if we were to go out one decimal point. which in this example, I'm not really doing. So let's reconnect those data flows that we had from our original maintain inventory example, as well as showing where the customer uh, or where the input for verify order details comes from. We also had a stock file, which provides input into verify order detail. There is an order history data store as well that we saw in our previous example. But now I'm just sort of connecting the dots, showing that the revised stock is saved in the stock file, and that serves as the current stock for verifying order detail. That order history, order requests are stored in the order history data store, and then that is used as data in the form of current orders for maintaining inventory. So as we said, this is a level 0 diagram. This has more detail than the context level diagram, which means a level 0 diagram is less abstract because it's more specific than the context level diagram. So exploding a diagram, as we did from our context level diagram to our level 0 diagram, means we're looking at more detail. And we can continue to look at even more detail. I can explode the maintain inventory process that I've numbered here as 2. There are 3 sub-processes in this example that are a part of maintaining inventory. And so I'm going to number those as well to be distinct. But since these are sub-processes of that higher level process 2, they're going to share that 2 as a prefix. So 2.1, 2.2, and 2.3. The inputs and outputs to and from maintain inventory that we have here, and I'm going to kind of get rid of those extraneous details so you can see them more clearly, which is important because those data flows are really data flows from these sub processes. And these sub processes also have data flows between them. So as I explode, as I level down into a level 1 diagram, and this is a level 1 diagram because it's 1 decimal place out. A level 1 diagram is more specific than a level 0 diagram. In the level 0 diagram, we had the process of maintain inventory, and in our level 1 diagram, we are being more specific about that process by showing its sub-processes. As an important point of note, the inputs and outputs to and from the process of maintaining inventory don't change as we explode from a level 0 diagram into a level 1 diagram. And as I add the details of our level 0 diagram back in here, it is what we call balanced. It maintains the exact same inputs and outputs throughout the leveling, throughout the exploding. And this is what we call balancing. Maintain inventory still shows those inputs and outputs. And when we had exploded it, we showed the sub processes that used those inputs and created those outputs. Similarly, we did the same thing, and we can see this exemplified in our context level diagram as well. That is, the data flows remain balanced as we move between our different levels. When we're creating data flow diagrams for a system, we are going to have multiple diagrams showing different levels with different detail within each level, but always ensuring that our diagrams are balanced between those different levels. And that wraps up this video on data flow diagramming. Stay tuned for one final video in which we create a data flow diagram together.